Hello everyone, my name is Josumar and this is my oral exam from analysis of electrical circuits. And let's start. And the first scenario, we have the protection of low power devices. In this case, it's a LED red one, and that operates with a voltage of 1.8 volts to 2.4 volts. Also, they can withstand up to 120 milliamperes of current without getting damaged. And although a nominal current of 20 milliamperes is the recommended for a nominal operation. So for the first question, we have what must be the value of R1 in order to power the LED with a voltage of 8.7 volts and use the recommended nominal current of 20 milliamperes. So to solve this question, we have to use the Ohm's law. We know the voltage, the current, and we apply the formula for the resistance, that is voltage over current. And we have finally 434 ohms for the resistance. This one. And okay, for this question now, if we only have resistors of 220 ohms and 100 ohms, it is possible to build the circuit as required, and the answer is yes, if we can use two resistance in series. If we put the R1 here and the R2 right there with a value of 220 ohms, yes, but if we only have a resistance of 220 and another of 100 ohms, it's not possible, and the LED will get damaged. Okay, for the second scenario, we have the analysis of a defibrillator. That is an electronic device that pretends to reestablish the normal heart rate by applying a high rate of voltage electric shock to the heart through the chest. Well, in the past, there was some models of this electronic device, but now we use modern ones that deliver from 150 joules to 360 joules for 20 milliseconds. That is the time of discharge of this of the capacitors. So using that information, electrical variables that must be considered to guarantee the max energy delivered in a modern defibrillator. We have to use the equation of discharge of a capacitor. And as we can see, we have to take into account the voltage source, the time, the resistance, and of course the current. And for the second question, to guarantee charge. To guarantee charge of the device in 10 seconds at most, what is needed? Using the charge of a capacitor formula is this one. And considering that we have the full charge at 360 joules, we need to know how these variables will work in the first equation, that is this one. So we replace the 360 in the left part, and this equals to the capacitance multiplying for the voltage source, and this multiplying one less earlier, elevated 10, that is the time, over resistance multiplied by the capacitance with a negative sign. So we have to modify the variables of the resistance, the capacitance, and of the voltage source to guarantee the charging that time. How to guarantee the max current? And for this question, we analyze that how the current works in a discharge of a capacitor. And we know that the max current is at the time 0. So to guarantee the max current, we have to fully charge our capacitor or capacitors, and then start the charge, and the max current will be at the very beginning of the discharge at the time 0, or at the very beginning of it. So we have to use the equation of current of discharging capacitor to calculate the current that will be discharged. So to calculate the power dissipated from a modern defibrillator in each shock with a minimum energy in the range, we have to use the formula of power, that is work over time. And we know the work, that is 150 joules, and the time, that is 20 milliseconds. So we have finally the result of 7.5 watts. Then to prevent the heart from receiving enough current, we have to be careful with the variables of voltage source. That is the thing that will be charging our capacitor. And we have to be careful to use a capacitance of 150 coulombs and 160 coulombs, and 360 coulombs. I have a mistake right here with the recommended it. Yeah, but because if we use a capacitance with a higher range, we will have a more violent discharge, and that's not what we are looking for. And that's all. Thank you.